So in question 8, we are told to use L'Hopital's rule to find this limit. Since the question tells us to use L'Hopital's rule, we don't really need to check that this is either 0 over 0 or infinity over infinity. Otherwise, usually for limits, we first need to check whether a fraction is in a 0 or 0 or infinity state to make sure that we can actually use L'Hopital, but the question says we can, so let's do it. So we always want to write down the limit. We always have to write down the limit until we don't plug it in. So we write it down and then we start taking the derivative of the top and of the bottom. So this secant to the 4th x, this is like just going to be a chain rule. The outside function is x to the 4th, or just this whole thing to the 4th. So it'll be 4 secant cubed x, and the derivative of the secant function is secant x times tangent x. And then similarly, the derivative of cosine will be minus 2 cosine x, and then the derivative of the inside function, which is cosine x, is minus sine x, and then this is all divided by 4x cubed minus 2x. Okay, so we can do some simplification here. So this will be the limit as x approaches 0 of 4 secant the 4x tangent x plus 2 sine x cosine x all over 4x cubed minus 2x. Now we could already try and substitute in 0 to see if we are lucky and we don't need to apply L'Hopital's rule again. But unfortunately, we're going to have to do it again. But we can just try. So 4 is going to stay. Secant of 0 is simply 1. Tangent of 0 is 0. And then plus 2 times, well, sine of 0 is 0, so we don't even need to look at the other one. And it's also going to be 0 minus 0, so this is still 0 over 0. So let's continue taking the derivatives. So limit as x goes to 0. And then here we're going to have to use the product rule now. But first we need to remember how we took the derivative of secant to the 4th x, as we're going to have to do the same. So let's do it. So what we can do here is, first of all, let's just take out the 4. It's a constant, so we don't really need to worry about that here. So we have this secant to the 4th x like this, and then times the derivative of the second one is going to be secant squared x, and then we add tangent of x times the derivative of the first one. Here I didn't write big brackets here, but we can just do 4 times 4 then, so 16, and then again secant cubed x, and then the derivative of secant is secant x times tangent x like this, and then we add the derivative of the second part. This is also going to be a product rule, so 2 sine x times minus sine x, and then we take the derivative of the first one, so cosine x times 2 cosine x. Okay, and on the bottom we have 12x squared minus 2. Okay, now yeah, we can maybe do some simplification. We could plug in 0 already, but might be easier if we bring some terms together. So this will be 4 secant to the 6 plus 16 secant to the 4th x tangent x squared minus 2 sine x squared plus 2 cosine squared x all over 12x squared minus 2. Okay. Now hopefully we're not going to have to do this again. So let's plug in 0. So if we plug in 0, secant of 0 is 1 minus plus 16 times the secant of 0 is 1 again times 0 squared minus 2 times 0 squared plus 2 times 1 squared all over minus 2. So it's good we don't have a 0 on the bottom anymore. So the first one will just be 4, then that's a 0, that's a 0, so we have a plus 2 over minus 2. This is 6 over 2, so this is minus 3.